There it is. Okay. We talked about when you need to keep the parentheses and when you don't. When you see a plus, you do not need to keep the parentheses. So you can just drop the parentheses altogether. 3x squared minus 4x plus 6 plus 4x squared plus 6x minus 7. Hopefully you remember me saying that, or because that's key. You know, really, you can't do much without that. So now you just combine like terms. What do you see as being like terms in this problem?
3x squared and 4x squared.
Yes, and those make 7x squared. So what some students do is they cross them out as they use them. And I like that. Just be careful not to cross out like the minus that goes with the next term. Okay. So the next term is minus 4x. What does that go with?
6x.
Okay. And what does that add up to? Minus 4x plus 6x.
2x.
Plus 2x, good. And you can cross them out. That way you know you've used them. And then plus 6 minus 7 is minus 1. All right, so number 9, related. Very much related here. This one has a subtraction in the middle. Okay, so you're gonna change the signs of everything inside parentheses to the right. So this 5x cubed is really positive, so that's gonna become negative. The 8 is positive, so it's gonna become negative. So you really just have to remember this change the signs, or if you prefer to multiply by -1, you get the same thing. There's nothing on the left here to hold the parentheses. There's nothing to multiply in. There's no subtraction symbol, so you can drop the parentheses like that.
Okay.
All right, now combine like terms. So I'd like you to give this one a try and let me know your final answer, please.
Minus 2x cubed plus 2x minus 8.
I'm sorry, I missed that. Did you say minus 2x cubed?
Yeah.
Plus 2x minus 8. Okay, I just missed that first one. Yeah, very good. All right, number 10. Number 10 here. All right, so this one's kind of the culmination, the summative, if you will, of the previous couple of problems. Okay. So the 3 is keeping the parentheses on the left, like because it's 3 times, you're going to multiply both of these terms by 3. Okay. On the right, and maybe we should do that first, but on the right here, it's really -4 times both of these. When there's a number, you really want the operator to go with it and treat it as -4. So 3 times 4x, 12x, 3 times 1 is 3, minus 8x, minus 28.
Four x minus 25.
Yes. All right, any questions on that before we move to 11?
No.
Okay. So 11 is like the first real math problem that you might actually see in the real world. Money problems are really, I think they're really wonderful in math. I mean, I wish they were given, taught more often. Some schools actually do have like a more of a I'll say a consumer math or like a financial math. So these could be more interesting. If they're not, that's okay. But there are two types of money problems that you will see. The first is non-continuous interest. And then the other is continuous interest. Continuous. My spelling is probably off on all these, but you get the idea. So it will always say if it's continuous, like it will literally say the word compounded continuously. Non-continuous could be any of the following. It could be annual, meaning yearly, quarterly, monthly, daily, weekly, things like that. This one is quarterly. So the reason I bring this up is there's two separate formulas. Like if you're using the one on the left, it's a certain formula. The one on the right is another. Okay. So we're gonna talk about the non-continuous formula. Here, I'm just reframing the question here. So the amount that you will have in the future is the amount that you started with, 1 plus the interest rate divided by the number of compounding periods to the power of n times t. N is still the number of compounding periods. T is the number of years. So there's a lot here. There's a lot like to remember, but they have to give you, there's 5 letters here. They have to give you 4 of the 5. Can you tell me any of these letters, what their numerical value is? I'll take any of them.
I think T would be 8 years.
Good.
I think N is 1/4, maybe.
N is actually 4 for the quarterly. Good. That's good though. That's you're on the right track there. How about P? What are you starting with?
Oh yeah, 7,500.
Good. Now the interest rate, so percentages are what adults use instead of the decimals. You never go into like a meeting and talk about decimals in the adult world. You always talk about it in terms of percents, but the formulas require it to be a decimal. So do you remember how to convert a percent to a decimal?
Is it divided by 100?
Yes. And in other words, you're moving the decimal left 2 places, 1, 2, and any place that's not filled, a 0 goes in.
Okay.
So 0.035. Now, do you have your graphing calculator today?
I've
Okay,
Desmos.
do you have Desmos Scientific?
Yeah.
Please, yeah, please use that. I'll drop it in the chat. But yeah, go ahead and put this in. So it's good to write it and then type it in. One of the nice things about Desmos Scientific is that you can get it in this form. You may have to, I'm sorry, 4 times 8. You may have to put parentheses around the exponent. But I will do the same thing. Let me know what you come up with for an answer.
Okay. I got 9,911. Rounded up.
What if we want to go to the nearest cent? What would it round to?
0.4.
Yes, very good. Does that number seem reasonable?
Yeah.
It has to be bigger. I mean, it's growing. But in terms of like like what does 3.5% look like? It's not a ton of growth, but that's okay. All right, 12. So 12 is exponential growth decay. All right. I think they want you to use something different in 12 than you have written. Do you know if your teacher said explicitly to use that?
That was a formula that she gave us.
But did she say for sure to use it for this question? Because it's not generally the one you would use for this.
What is the one that was most recommended?
So there's PERT, and then there's PAT. Maybe you've seen those. I believe PERT is what they probably want here.
Okay.
So the function P is the starting amount, R is the rate of decrease or increase, and your variable is T. So in this problem, think of 650 as your starting amount. Now a decrease, the percent becomes negative, or R becomes negative as a result of the percent. So question to you is, what is 4% as a decimal?
0.04.
Okay, so it's negative 0.04 because it's decrease. If it said increase, then it would be positive, and then T is your variable. Now, because it's a function, you're really supposed to put like f of t in front or some sort of a function operator. Okay, so use Desmos again, and this time you're going to put 5 in for t. And let me know what you come up with.
Uh, 88.
88 is way too small. Let me show you the way I've entered it. I'll just snip that in, and then you can tell me if you have something similar or what your error is. Do you have a new answer?
Oh, I put the decimal in the wrong place.
Okay. What did you end up getting? What's your
Classic mistake.
I'm supposed to say that. That's my line. What's your final answer?
532.2.
So it's money. We really should go to 2 decimal places. You ever seen the movie Office Space?
No.
So these guys, it's kind of an older movie, but these guys, they play around with decimal points, and they end up stealing from the company because they're like, oh, they won't miss, a 10th here, a 100th here, and it doesn't work out so well for them in the end. So the decimal points do matter. Companies do care about that. If you ever work a job where you've got a change drawer, they really want to make sure you have the correct change at the end of the day. Correct money in the drawer. All right, let's move on to 13. All right, new question here. All right. So certain fungus has a half-life of 7 years. There is a shortcut for using half-life. Did your instructor give you anything like that? Like K equals natural log of 1/2 divided by T. Did you see anything like that?
Kind of.
Okay. We can do it explicitly, and we probably should. It'd probably be a good exercise for us to do. So we're going to use PERT again. PERT. Now, 80 is the amount that you're starting with. Okay, and there's actually two parts to this problem. We're just going to deal with finding the value of R first, and then we'll write the function. So 80 e to the RT is our function for right now. We really need to find R. In the previous problem, it was just given. Okay, so let me know when you get caught up to that point.
Yeah, I got it.
All right, now, if we want the half-life, half-life means you have half of what you started with. So what is half of what you started with here? What would that be?
40.
40. Okay, now how long does it take to reach a half-life?
7 years.
7 years. So now there's only one variable left. Okay, so we're gonna solve this together. We're gonna solve for R. We're gonna first divide both sides by 80. 40 divided by 80 is 1/2. E to the 7R. All right. Now, the next thing is you're going to take what's called the natural log of both sides of the equation. Have you seen that?
I don't think so.
Okay. So your teacher is I don't, yeah, this is new, but I guess that's why that formula was there. Okay, so let's do it differently here. I guess you're not using PERT. I mean, I hate to backtrack, but I guess you're not. Would it be too much to redo 12, and or do you think 12 is fine? There's not. Go ahead.
Because if I did it a different way, then it wouldn't have a different outcome. Would it?
They're related. So Pat and Pert are related, but what I don't want to cause you is like you go to your teacher and they're like, "How did you know this? We haven't touched this yet," and then you get and have a problem because of that. Is what I'm trying to say.
Yeah, we do 12.
Okay. All right. So let me just reframe this. Okay. So the other formula is you have an initial amount and then it's 1 plus R to the power of T. Okay. But it could also be 1 minus R to the power of T. Does this look more familiar to you?
Yeah.
Okay, that's good. Now, if it's increasing, we use the first one. If it's decreasing, we use the second one. What is the value of R?
4%, so it'd be 0.04.
0.04. So we're going to use that in the second one. So your function is the amount that you have in some time in the future is how much you started with, 1 minus 0.04 to the power of T. So I'm just putting 650 in for P and 0.04 in for R. And then this reduces to 650 times 0.96 to the power of T. So that's your function. That's your first box there on the left. First line on the left. So now I I want you to go to Desmos and type this in, but use for t the power of 5.
Okay.
And this actually does look, I would say this probably is what your teacher wanted, now that I see the answer.
Got 500 and 529.99.
Yes. And that kind of looks like a price tag you might see out there. Okay, so let's kind of redo 13. So the same thing applies here. If it's growth or it's decay, it's the 1 plus R, 1 minus R. So whenever it's half-life you want to think of as decay or decreasing. So it's P times 1 minus R to the power of T. Okay, so that's what we're starting with. So very similar though, it's 80 1 minus R to the power of T, but then we make some changes here because we're interested in figuring out R, we're not given R. We have to assume that half is left and replace T with 7. Okay, so to solve this, you still divide both sides by 80. Okay, and now you have to undo this power of 7. Okay, how would you undo a power of 2? Do you remember that?
I don't think I do.
Okay, so it's called a square root. Let me just give you the answer because that takes some explanation. So you're gonna undo this power of 7 with what's called a 1/7 power, like that, and you have to do it to the other side as well. So you're actually raising it to a power of 1/7. So it looks like this: 1/2 to the 1/7 power equals 1 minus R. And our goal is to solve for R, or this 1 minus R. So but let's not do that. So to solve for R, you're going to add R to both sides. So you have R plus 1/2 to the 1/7 power equals 1. And then you're going to subtract both sides by this 1/2 to the 1/7 power. So R is equal to 1 minus 1/2 to the 1/7 power. So if you've still got your calculator up, please calculate that for us. Let's go to 4 decimal places.
0.94.
One more.
2.
Rounds to 3. We'll go up to 3.
Oh,
Okay,
yeah.
good. Okay, so all of this work, and probably you need more explanation, but let's just go with it for the moment here. All of that work to figure out that this function it's 80 1 minus 0.0943 to the power of t. Okay, so you can you can subtract and you get 0.9057 to the power of t. And then to find the amount, you have to use the given t value. So you have to put t equals 42 into the equation. So go ahead and multiply and power 42 and let me know what you come up with. It's not very much that is left.
Uh, 1.1 or 1.2425.
Yeah, good. Good. Okay. Any and units. It should say pounds. That's a small thing, but they would probably mark you if you were taking a test or quiz on that. Let me know when you get all that down. We can move on.
All right.
Okay, so I'm looking at the next thing for us to move to is the on the screen there, the find each product and completes parts A through D, or do you want us to do the other one, the find a value of M or N?
Let's go with this one first.
Okay. So I take this to mean that this is part A and we'll get part B. So for part A, you're going to FOIL, and we did this last time, so I'm going to ask you to just attempt to tell me what the right answer is.
Okay. 2 squared plus 18x plus 81.
So x squared plus 18x plus 81, is that right?
Yeah.
Okay. So I'm pretty sure the way this system works, you got to hit enter that or put that in and hit enter. Do you want to do that now?
Yeah.
Do you want to wait?
Yeah, I'll do it later.
All right, so why don't you try the next one? And the idea here is that there's like a pattern to be seen.
I got x squared minus 14x plus 49.
Good. So these are both what are called perfect square trinomials, and they have a formula or a pattern. The last one, part C, the 2x minus 1 squared, you're supposed to know that, oh, I can't do it the way it's written. I have to separate it out. And you want to do that before you FOIL. So go ahead and multiply that out. If you have questions, please ask.
I got 4x squared minus 4x plus 1.
Yes, perfect. What is part D for this?
I think it's a typo.
Okay. So you're welcome to send over more pictures, or we can go to that other page, whatever you think would be best for you.
Probably go to that other page. Whichever was. Let's see.
All right. Yeah, let me get that up. So this one, I actually think this is a good problem because it's sort of like going backwards where you have to, they're not just saying, hey, do the FOIL. You have to kind of know like where it's coming from. And these are usually harder for students. So let's look at A. Hopefully I didn't make it seem like it's impossible. So you could, for example, you could just FOIL this, and that will tell you the correct answer. Okay. But you're supposed to also recognize this is actually difference of squares. And with difference of squares, the O and the I, they always cancel. Okay, and then you'll see that here. So it's 9x squared minus 18x plus 18x minus 36. Do you agree that the O and the I cancel?
Yeah.
Okay, so what are you left with?
9x squared minus 36.
Yes. So the shortcut, though, is to say, oh, to get M, and this is, by the way, what you would see on an SAT, ACT type test, is just multiplying these two. That gives you the value of M. Now, if you FOIL it, you still get it, but you can do it faster. So if you saw me send you an invite to a SAT, ACT prep class, that's the kind of stuff I cover, some shortcuts for that. But the value of M, just to be clear here, M is equal to 9. Any Anything you want to ask me about that, or anything that I didn't make clear before we move on?
It's pretty clear.
All right. Part B. Part B here, what you could do is you could FOIL the left. You don't have to, but you could. A better strategy is to recognize, how do you get the first term from foiling? I guess I'm asking you, not asking rhetorically. I'm asking you. Yes.
Do the FOIL it.
Right.
Or,
But to get the first term, you just have to take the first times the first.
oh yeah.
So mx times mx is m squared x squared.
Yeah.
So now you pair that with the 4x squared.
Okay.
So what is the value of m such that when you square it, you get 4?
Oh yeah, because m is 9. So. I don't know. I feel like I'm not getting something.
That's okay. Yeah. So it's m squared equals 4. So you're just taking a number, multiplying it by itself to get 4.
Oh,
And
2.
2. Yeah. Maybe I
I
didn't
don't know
ask you
why
clearly.
it took me that long.
That's okay. Sometimes I don't know if I asked the question right, but yeah, m is 2. Now it could be -2, but we'll see later on that it is not. Just like we did for the first term, you want to do for the last term. To get the last term, it's ny times ny. So it's very much the same. Ny times ny equals n squared y squared, and that equals 9y squared.
Okay, so
What is the value of n in this problem?
3.
Yes.
It took me a second.
Well, good news is we've gone through everything that you have sent over, and we have some more time. So if you want to queue up some more pictures, you can drop them in the chat and give you the email address, whatever is easiest for you at this point. I assume there's a few more to do. It says like 1 of 2 and 1 of 7.
I didn't know how much we were gonna get through, so
Yeah.
Okay, so I got questions.
Okay.
Yeah. Are you still there?
Yes. Did something come up? I'm checking the email here. I don't see anything that's come through.
I'll maybe
Either email or drop it in the chat. Sorry about that. I just over the years sometimes I don't say much if I don't have to say my voice for future.
Yeah, kind of the same.
I can also make you co-host to share your screen if that's ever easier. Whatever it takes to get the problems. Still not seeing anything come through. There it is. All right, let's see what we can get done here in the bit of time we've got. Okay, that one, not too bad. All right, we're gonna do this 7.5 first. Or 7.3, find the area of the shaded region. We'll get that one down. Okay, here we go. So the idea is that the shaded region is made up of a large square and subtracting a little square. The large square is 4x minus 6 times 4x minus 6. The little square is x times x. Okay, so you've got to find the area of the big one first. So you have to take 4x minus 6 and multiply it by 4x minus 6. So that's 16x squared minus 48x plus 36. I'm just going through this a little fast just to make sure you get something down here for this. But then you have to subtract out the area of the little one. The area of the little one is x squared. So this is where you have to combine like terms. So 16x squared minus x squared becomes 15x squared minus 48x plus 36. And then the units, inches times inches is inches squared. So let me know when you get all that down. We'll definitely be stopping here.